Alright, for this one we'll try and get through, I don't know, 10 through 16 maybe in this video, all on this slide. Okay, what's the slope of this line right here, number 10? Slope, we should know, is delta y over delta x. And so for us, we'll call this x1, y1, x2, y2. So we have to go, it doesn't matter as long as you're consistent, and this is the most standard way to do it. Oops, x1. Let's go y2, 25 minus negative 5 over x2, 8 minus 3. That's 25 plus 5 because we have the double negative. 8 minus 3 is 5. So 30 over 5, our slope is just 6. Problem 11. What is the slope of this line? We always solve for y. Y equals 23. Now remember, the equation for a line is y equals mx plus b. The mx is missing from y equals 23. So m must be equal to 0. We just have y equals b because the m is 0. M equals 0. Okay. An alternative way is to recognize right away that y equals 23 is just going to be a horizontal line at 23. And all horizontal lines have a slope of 0. And number 13, what is the slope of the line of x equals 6? We can't solve this one for y. And again, it's one of these funny lines, and we just have to memorize x equals 6 is all the x values, or all the points that have an x value of 6. So we'd mark 6 right there. And those lines that are vertical, slope is undefined. We cannot put a number to it. The slope of y equals 5x plus 3. That's in the form mx plus b. Slope equals 5. We can just read it straight out of the equation when it's solved for y in that fashion. Number 15, what is slope of this next equation? We will solve for y. And dividing by negative 2 everywhere, we get negative 3 or negative 2, which is positive 3 over 2. And 12 divided by negative 2 is negative 6. So the slope is 3 over 2. Again, just reading it out of the equation. Which line is steeper in number 16? This one has a slope of negative 5. The negative just means it goes up and to the left. The second equation, we still need to divide by 2. And we get 4x minus 3 over 2 when we solve it for y, so we've got to get rid of that coefficient. It has a slope of 4. So even though the slope of the first one is negative, the 5 being bigger makes it a steeper line, and so it is the steeper slope. Alright, that hasn't taken too long, so we'll make a new page, and we will continue on in this video. I believe we were at problem number 17. Throw those up there. Alright, continuing on. Let's make this just a little bit bigger for you. Maybe we can get it all in there. Alright. We got an equation. It says put it in standard form, but they tell us what standard form looks like, and I will do the same thing for you guys on the final if I ask for this. Negative 2/3 x minus 4y equals 1. The key thing is x and y have to both be on the left-hand side, which they are. Another thing, though, we talked about was no leading negatives and no fractions, and this has got both. So to eliminate that, we're going to take both sides times a 3 because that gets rid of the 3 in the denominator. And if we make it a negative 3 that we multiply by, it will get rid of both the negative and the denominator all in one step. Okay, so what's going on here is you distribute that negative 3 to each term. I'm going to do the same thing to the other side to keep it balanced. And when you take negative 3 times the negative 2 here, you get a positive 6. Okay, but that number has a 3 in it. That's why we multiply by 3, so it's going to cancel out and just give you 2x. Negative 3 times negative 4 is positive 12y. No denominator to cancel there. And the right-hand side we get negative 3. And so there we are in standard form. And the leading coefficient of x here is positive and not a fraction. What's the y-intercept of this linear equation? A couple of ways to do it, and I think probably the easiest is just let x equal 0. Because when you're on the y-axis, x has to be 0, which means 3 times 0 is 0. You just have to solve it and find out what y is. Y is negative 3. That's your y-intercept. The point, 0, negative 3. We got a few graphing ones. I got the graph set up right here. This is already in slope-intercept form. Slope is 2. Y-intercept, b, is negative 4. So we mark negative 4 on our graph, and we go up 2 over 1, because our slope is 2. You can draw several of those in there. And that is our line. Let me get the line tool here. There's our line. Next one we'll do in red. We'll solve this thing for y. So it's in slope-intercept form. Y equals 3 halves x minus 3. Y-intercept, negative 3, which is right there. And slope is up 3 over 2. That goes to the same, one of the same points. 1, 2, 3 over 2. 1, 2, 3. Well, my purple one's off a little bit, but my red one, having a different slope, we know it's not going to be parallel to it. So the red one is going to be a little bit different. Yep, up 2 over 1, up 3 over 2. Okay. Something like that. Not a very good job graphing, it looks like. And then the last one, we'll put that one in some sort of green color. We'll add 2 to both sides. Y is 5. 1, 2, 3, 4, 5. And that's going to be, therefore, a horizontal line at y equals 5. Just like that. And we'll stop that video.